Now, we need to be able to interpret what this is. So we're going to say that, what do we use to estimate the true intercept? What do we use to estimate the true slope? What do we use to estimate the true standard deviation? And then what is the standard error of the slope? Okay, so there's a lot going on right here. What do we use to estimate B sub naught? Well, or beta sub naught. We use B sub naught. So B sub 0 estimates beta sub 0. B sub 1 estimates beta sub 1. Okay. S estimates sigma. Huh. No real surprise there. Okay. That shouldn't be much of a surprise to us. And then we'll talk about the standard error of the heights. Okay. So what is the estimate of B sub naught? What is the estimate of the true intercept? Well, the true intercept is negative, or the estimate for the true intercept is negative 0.03761. I get this from reading the printout, the slope. Okay. How do I estimate, the intercept of the line, which is underneath the coefficient? How do I estimate the true slope of the regression line? I use the sample slope that I found from this regression line. So 0.005724 is my estimate for beta. How do I estimate sigma? I use S. So this is going to be the easiest part of this whole chapter. When they ask us these questions, all we do is say, oh, B sub 0 estimates beta sub 0. B sub 1 estimates beta sub 1. S estimates sigma. And the standard error is always found here, standard error, but we want the standard error of B sub 1, which is the slope. So it's always going to be the constant is B sub naught, and the variable is B sub 1. So what is the standard error in this case? It's, for question D, it's 0.002018. Well, what the heck does that mean? In repeated random assignment, many times the slope of the regression line would vary by about that much. So the slope of the regression line would, on average, vary by approximately 0.000218. So the standard error B is the standard deviation of the slope in repeated measurements of the same problem or the same experiment or whatever it is that we're working on. Okay. That's going to be the easy part for us. Now let's actually calculate a confidence interval for the slope. Well, just like before, every confidence interval in the world has the same form. It has an estimate plus or minus a margin of error. Now, how do I estimate beta sub 0 or sub 1? How do I estimate the true slope of the regression line? Oh, I use B sub 1 as an estimator of beta sub 1. And this is going to be a t interval. So for regression inference, we use t times the standard error of B sub 1. No surprise there. Okay? We always have the standard error behind the star. So the standard error of the slope has this crazy looking formula. So the standard error of the slope is equal to the square root of the summation of y sub 1 minus y hat 1 squared over n minus 2 divided by the square root of the summation of x sub I minus x bar squared. So you take each individual y and you subtract its prediction. Hey, observed minus predicted. We've heard that before. That's a residual. Okay? Where this top piece is just a fancy way of saying the standard deviation of S. It's the standard deviation of S, or it's the standard deviation of the residuals. Okay? And then you divide that by the square root of the summation of x sub I minus x bar squared. Okay? I know this is crazy, but for the most part, we're going to be looking this up in a table. The other weird thing about doing inference for regression is that there is n minus 2 degrees of freedom instead of n minus 1. We're not going to get into why that's the case, but we're just going to have to believe them. So instead of looking at n minus 1, we'll look at n minus 2. To look up a p-value in the table, we're going to have to use the table B or the t-distribution chart to find that. Okay. Well, let's put this all together and let's run through an example of this. Everyone knows that cars and trucks lose value the more they are driven. Can we predict the price of a used Ford F-150 if we know how many miles it has on the odometer? A random sample of 16 used Ford F-150 Super Cruise was selected from among those listed for sale on the Auto Trader. We did this problem before. I think this problem was in chapter 3. The number of miles driven and the price per dollar were recorded for each of the following trucks. Here's the data. Okay. Underneath, they give us a computer output. They give us the scatter plot with the prediction line, and they give us the residual plot. We need to construct and interpret a 90% confidence interval for this. Well, we looked previously at the formula for the confidence interval of the slope of a regression line. Remember, every confidence interval is estimate plus or minus margin of error. So that's the formula we're looking for. Well, how do I estimate beta? I use B. So if I look at the computer printout, what is the estimate of this? The estimate of the slope, it's negative 0.16292 plus or minus T star. Well, how many data points are there? 16. Remember that the degrees of freedom is always n minus 2. So 16 minus 2, we're looking for 14 degrees of freedom. Let's find the T star at 90% for 14 degrees of freedom. Let's get our favorite table over here, and let's find table B. Table B, 14 degrees of freedom, and I would like to be 90% confident. 14, go over here to 90. That's 1.761 is my T star. 1.761. That's my T star that I'm going to use. Now I need to find what is the standard error of B. Okay. The standard error of the slope. Remember, that's also given to us in this computer printout. The standard error of the slope, standard error in the slope. So the standard error for us is 0.03096. I'm going to multiply those two values together. So I'm going to have negative 0.16292 plus and minus 0.05452. So I'm going to add and subtract those, and I'm going to come up with an interval of negative 0.21744 to negative 0.1084. All right, so I am 90% confident that the true slope of this regression line is somewhere between negative 0.21744 and negative 0.1048. But I haven't put that in context of the problem yet. Okay. Really, we need context for this. We need to explain what does that slope mean in context of this problem. So our regression equation was the price, how much the truck was worth, was equal to 38,257 minus 0.16292 times the number of miles driven. Now I have context to put this into. So what I can say is that I am 90% confident that the true amount of money that the truck will decrease by. That's what I'm trying to find. So does this mean in context of this truck? For every 1 mile driven, I am 90% confident that the price of the truck will decrease somewhere between 22 cents and 11 cents. So I am 90% confident that the true value of my truck will decrease by somewhere between 11 and 22 cents for every 1 mile I drive.